Here's how to make a fairly cheap, do-it-yourself solar charging station. What you're going to need is a solar panel, the battery pack from my other video, and a solar charge controller. Then we're going to go ahead and build this wooden stand, which only costs $7 to make. General prices on this stuff: Kyocera KC130 solar panel. They now have the KC135 with the junction box on the back. It's about $350. Morningstar charge controller is about $100. The Walmart battery pack that I put together in another video is $83 with a brand new Group 24 Marine Deep Cycle battery inside it. Then your Ryobi tool charger is another $39. They have a new version that's green and black that's sold at Home Depot. Let's take a look at how we're going to put all this stuff together. We're going to make a cradle for this thing so we can set it on the ground and attach a battery pack to it. This is what each side is going to look like. It's 32 inches on the bottom, 25 1/8 on the back side, 15-degree angle here, 15-degree angle here, a 13.5-inch piece on the front, 15-degree angle cut, 45-degree angle cut here, and the top bar is 25 1/4. This is where the solar panel is going to be attached to. This specific setup puts the solar panel at a 30-degree tilt angle, which is a good compromise for pretty much anywhere in the northern hemisphere. Now you've got enough for 2 side supports. If you don't have any glue, you can just put screws in here and screw this whole thing together. I'm going to use hot glue on all the joints. Then go ahead and put your screws in. One side complete. Alright, 2 supports done. Set the panel on a table or get some friends to help tilt it up while it's on the ground or something like that. Then take your cradle sides, mount them into the panel very carefully. You don't want to hit the back of the panel, you don't want to drill into the junction box. It's best to just set the wood up along here, mark it, and pre-drill your holes with a drill bit right on the spot. Then go ahead and put your screws in. Okay, we've got both sides on. It's looking pretty good. Now we're going to add some crossbars onto this thing to keep it all together. Okay, there we are. A couple 59-inch crossbars added on the bottom here. And all you do is, measure from the wood you're attaching to the sides of the panel, one end to the other, and that will give you the width of your crossbars here. Okay, back up to the table for a little bit because I'm going to show you some stuff about how to wire this. Okay, now we're going to need to get some wires into this junction box. Usually on the side of the junction boxes, there's either a hole that you can knock out, or it may have a weatherproof connector on here, which is basically a big nut that screws on. And as you screw it on, it tightens an insert down that grabs the wire and makes it waterproof. Unscrew the retaining nut off the waterproof connector. Slide it onto the wire, facing the proper way, down about as far as you're going to insert the wire into the box, and force the wire through the rubber waterproof insert. Just keep pushing, grab the other side of it, and pull out about an extra foot. Now slide your nut down and tighten. Now you have a watertight connection to the box. Next, we're going to put a connector on the end of this. A couple different types of spade connectors can be used to attach your wire onto the terminals in the box. There's the cheap spades, which you can find at Walmart. See how they're just straight? Then, this is a marine grade spade. See how the forks have like these little bend in the end of them? That's so when you attach them onto the screw and tighten the screw, kind of holds it on there a little bit. These are the better ones to use. So go ahead and strip the end of your wire and crimp on a connector. Okay, so here we are. We've got 2 wires now mounted into the box. with spade connectors, which will screw onto the terminals inside the junction box. And here's our 2 lengths of wire. You want to use 10 gauge for this. This happens to be 8 gauge because I had some laying around and I made it fit, so that's alright. But you don't really want to go smaller than 10 gauge if you can help it. If it's a very short run to a small battery, you could use 12 gauge. That's fine too. Next, we're going to set up a charge controller, which basically goes between the solar panel and the battery pack. And what this does is this regulates the charge from the sun to the battery, and when the battery's full, it disconnects the solar panel. It does a bunch of other things too. This one has load terminals and stuff like that. You want to get a good brand. Pretty much anything by Morningstar is pretty good. This one was about $100 for this 15 amp controller right here, and they go on up in price into the outrageous. You want to get something that costs about $100, and this will be decent. You're going to find all those cheap ones at Harbor Freight and other places, little tiny ones that are, fit in the palm of your hand. Most of those are total complete junk. You want to get something like this that's pretty substantial. Got a good heat sink on it, and it's just a nice solid unit made by a reputable company. Okay, we're almost ready to hook everything up. What we have is a positive and negative coming from the solar panel into the charge controller, positive and negative. It's labeled on here with a little sun icon. Then what we're going to do is we have 2 short cables made up with ring terminals crimped on the end. These will go to the battery terminals on the charge controller. So we have positive and negative coming off the charge controller and going to the battery inside this battery pack that I made, and with the cigarette lighter mounted on the front. Now you'll want to be kind of careful when hooking all this stuff up. Right now I don't have a cover on the panel, and I'm going to go ahead and throw a tarp over that so I can finish the hookup on all this. You want to just kind of hook it up in a pretty safe sequence. Don't cross any of the wires or any of that kind of stuff. And yes, the battery pack is fused inside here on the cigarette lighter outlet, but the charge controller going to the panel and from charge controller to here, there's no fuse connection in here right now. This is just a real simple video showing exactly how it's put together. Like out in the field or possibly in a developing country, you may not have a fuse holder. Safety Nazis, don't watch this video, okay? This video is not for you. Okay, we're almost getting ready to hook all this stuff up. We have a cover on the solar panel, so it's not producing any power right now. What you're going to do is you're going to hook up the positive and negative from the battery to the charge controller first. Then the charge controller will come on. You'll see lights on it. That will give you the state of your battery, state of charge basically. So you'll get a red, green, or yellow on here. Then what we're going to do is we're going to go over to the junction box and we're going to hook up the positive and negative off the solar panel itself. Then we're going to pull the cover off, and then we're going to get charging happening here. Now remember, there's no fuses or anything like that here because we could be in Athens, Greece right now. The city's in flames. There's no fuses available down at the local Greek Radio Shack, something like that. We could be in a country where all we have is some wire and we manage to find a couple of these pieces and we put them together. Plus, I don't actually exist. I'm a ghost, so I'm not affected by any of this stuff. I don't have to worry about shocking myself or anything on here. So, it's all good. Okay, here's a closer look. This is all very low budget, very simple. We have positive and negative wires coming off to the charge controller. There's a fuse in here going to the cigarette lighter outlet. That's fine. We're all tightened down good there. Now here's the charge controller. If you look really close, you'll see we've got a faint green in here. Probably can't tell on the video. Here's a close-up of the front panel. We have positive and negative to the battery, positive and negative of the solar panel. These load terminals, what you can do is you can actually run things off of this. When the battery gets down to a certain voltage, it's going to go ahead and disconnect whatever's attached to the load terminals. So what you could do is, if you had this mounted properly on the box, vertical, because it's got a heat sink on the back of it, say it was mounted on the front, you could take the cigarette lighter, positive and negative, and run them off this load terminal, so that whatever you have plugged into the cigarette lighter when it gets down, when it drags the battery down too low to, I believe, 50% or whatever this is set for, it will go ahead and disconnect the power to this outlet automatically, thereby saving your battery. So it's a good idea to do something like that. But this is kind of just a quickie setup just to show you how it's done. Okay, now we're going to take our two wires here and we're going to connect the negative and positive of the solar panel. Positive and negative are now tight. Tighten up the weatherproof nuts on the outside here a little bit, and go ahead and close the box. And go ahead and replace the screws. And your connection is done and we're almost ready. Go ahead and remove your cover on the solar panel. And now, assuming you have some sun, you'll be charging. Set your multimeter to DC volts. Go ahead, put your positive on, put your negative on. You'll notice our battery's charging right now. 14 volts, 13.99, 14 volts. So that means we're getting something. Just go ahead and plug your Ryobi charger into the pack, and you can see we're charging. Another thing you can do with this pack, go ahead, get yourself one of these 5-volt USB adapters, plug it in, and you're charging cell phones, iPods, and whatever else through this pack. Another good thing to plug into the power pack is a really good quality AA or multi-battery nickel metal hydride charger. And what you can do with this is, if you have quality batteries like Sanyo Eneloop or something like that, these are very low discharge, high grade, rechargeable nickel metal hydride batteries. They don't have a memory or anything like that. They stay charged for up to a year. They're basically great for a lot of uses. What you do is, you go ahead and you can get one of these little Coleman lanterns. They now sell these at Walmart for about $19. It's a small pop-up unit, kind of waterproof, kind of shockproof. Takes 4 AA batteries, and it's really bright. These things can be used in your house or out in the field or whatever when there's no electric power. So a small unit like this will actually light up a room enough to get around and see and operate and stuff like that. Perfect thing to have in case of emergencies. Also, if you get nickel metal hydride D batteries, they're pretty expensive. They're about $50 a pair. You get 4 of them and you can run larger lanterns. They have supersized versions of this light, and you can do quite a bit with them. They'll seriously light up a room and allow a bunch of people to get around easily. Another thing you can plug into a jumper pack is a good inverter like this. This is an AC Delco brand. It was actually pretty cheap, but it's a pretty decent one for what it comes with. It says it's a 400 watt. You can go ahead, plug all kinds of house power things into this, up to a certain amount, within reason. And what this does is, on the back, this model comes with a removable cable. This cigarette lighter cable, as you notice, it says maximum 90 watts. That's all you want to run through the inverter when it's plugged in this way. It has screw terminals on the back. You go ahead, just loosen those, put on the optional cable that comes with it, and then you can hook it to the power pack directly, not through the cigarette lighter output, so you can use the full 400 watt output of this. With this you can run lamps, you can run some small power tools, you can run soldering irons, a whole bunch of different things off this. If you happen to have some chargers that aren't 12 volt, you can run some chargers through these, not all. I wouldn't try running some tool battery chargers, because my friend actually had them blow up on these cheap modified sine wave inverters. But then again, like I said, these are cheap. If you want to get a high quality version of something like this, they start at about $200 and go on up. They are full sine wave inverters, and you can get many small compact versions like this. Usually they're only about 125 watts for that price, or sometimes around 300 watts. But they're much better quality. You can run computers, laptops, all kinds of things off of them without blowing things up. So what you're looking at here price-wise is $573 for this entire setup, plus a Ryobi battery charger. This is so you could charge your tools anywhere. It's not cheap, and this stuff is not Harbor Freight stuff, except for the Walmart quality battery and power pack I made. The rest of this stuff is nice pro-grade equipment. Once you put together about a $600 setup like this, you're ready to power your shelter.